What are the various factors influencing adsorption? The first one is nature of adsorbent and adsorbate. We know that adsorption is a surface phenomenon. So as the surface area of the adsorbent increases, the extent of adsorption also increases under the given condition of temperature and pressure. Similarly, the extent of adsorption depends on the nature of adsorbate. We know that permanent gases like hydrogen, nitrogen and oxygen, which have very low critical temperature, whereas ammonia, hydrogen chloride, chlorine, sulfur dioxide, which have quite high critical temperature. Therefore, we can say that these gases, that is ammonia, hydrogen chloride, chlorine, sulfur dioxide, etc., are easily liquefiable gases. Easily liquefiable gases are adsorbed more readily than permanent gases. The second factor influencing the extent of adsorption is temperature. Now, what is the effect of temperature? The first figure represents physical adsorption. In the case of physical adsorption, extent of adsorption decreases with the increase in temperature. So as we increases the temperature, what happens? The extent of adsorption decreases. Why? Because in the case of physical adsorption, no activation energy is required. So on increasing the temperature, desorption will occur. That is, the adsorbed molecule will easily escape from the surface of adsorbent. Whereas in the case of chemical adsorption, it requires activation energy. So on increasing the temperature, the molecules get activation energy and get adsorbed on the surface of adsorbent. So in the case of chemical adsorption, the extent of adsorption first increases with the temperature and reaches a maximum and then decreases. After attaining a particular temperature, then the extent of adsorption decreases. That means desorption will occur. The third factor is pressure. What is the effect of pressure? From the graph, we can see that the extent of adsorption increases with the pressure and reaches a maximum, and then it becomes independent of pressure. The pressure at which the extent of adsorption become independent of pressure is known as saturation pressure. So we can say that after attaining the saturation pressure, the extent of adsorption become independent. Independent of what? Independent of pressure. Okay. Now, in the previous slide, there is a term adsorption isobar. What is adsorption isobar? Adsorption isobar is a plot that represents the variation of extent of adsorption with the temperature at a constant pressure. Constant pressure plots are known as isobar, and in adsorption isobar, it represents the variation of extent of adsorption with the temperature. But now, what is adsorption isotherm? Adsorption isotherm represents the variation of extent of adsorption with the pressure at a constant temperature. Okay, thank you.